In today's lesson, we're going to learn how to take something that's big and complicated like this and turn it into something much simpler to work with like this. It's all about simplifying fractions, and all you need to know is how to factor. Suppose we have these two expressions here, one in the numerator, one in the denominator. We begin by factoring them, and then we cancel out the things that are identical. So factor, cancel, and then you have your answer. Let's try a couple of these examples ourselves. In our first example, we have x squared over x squared plus 4x. We simply begin by factoring all of the polynomials. We look at the numerator, see if anything factors. We look at the denominator and ask ourselves the same question. We factor, we have x squared over x times x plus 4. Now that we've done that, we can cancel and reduce our fraction wherever possible. Notice outside I have an x and an x squared. Those I can reduce. That gives me my final answer of x over x plus 4. Now you do have to be careful here. Sometimes it's tempting to cancel those two x's. But wherever you have addition or subtraction, you have things that are connected. Because you have x plus 4 in the denominator, you would have to have exactly an x plus 4 in the numerator. The reason I could cancel the x and the x squared before was simple. Notice that neither of them had a plus or a minus attached to it. In example 2, we begin by factoring all of the polynomials. Please factor the polynomials now, pause the video, and come on back when you're finished. Let's see how you did. When we factor, we get x minus 6 times x plus 1 over x plus 1 times x minus 1. The next step, we cancel and reduce wherever possible. Please pause the video here and cancel anything that you can in the expression. We have an x plus 1 and an x minus 1, so we cancel those, and we're left with an x minus 6 over x minus 1. Once again, we cannot cancel those x's. They are attached to a number, namely the 6 and the 1. Now let's jump ahead to example 5. This one is for you to try. Begin by factoring, then cancel things that are identical. Finally, once you do that, state your fraction in simplest form. Please pause the video here. Let's see how you did. We began by factoring, and then we canceled things that were identical. That gives us 2a over 2a plus 1. And that's how you simplify rational expressions. But hold on one second. There actually is one last step that we haven't done yet for any of the questions, but we really should have. Because we have fractions with values in the denominator that are variables, we have to state the undefined value. Because remember, whenever there's a variable in the denominator, we run the risk that it could become a 0. So here's what we do. We look at the denominator of the fraction that we factored everything out in before we cancel anything. We look at those pieces, in this case the 2a plus 1 and the 2a minus 1. We write two equations, 2a plus 1 equals 0, 2a minus 1 equals 0, and then we solve those to get the undefined values. If a is negative 1/2, we will have something over 0. If a is positive 1/2, we will also get something over 0. So we say at the end, undefined at a equals negative 1/2 and positive 1/2. If we go backward, really in example 1 we should have done the same thing. Undefined at x equals negative 4 and x equals 0. And once again, in order to do that, I only looked at the fraction denominator. Finally, example 2, we should have said that we're undefined at negative 1 and positive 1. So, since we're talking about the idea of simplifying these fractions, we might as well also talk about opposite factors. Here's something really cool. If you have two opposite factors, you can cancel them out, and they cancel to negative 1. So, what exactly are opposite factors? Let's just take a look at that first. If you look at the fraction, in the numerator we have a positive x, in the denominator we have a negative x. Those are opposites. They have the opposite sign. Notice in the numerator we have a negative 3, and in the denominator we have a positive 3. Those are opposites. They're often written, as you see on the screen, x minus 3 and 3 minus x. So why on earth do these cancel to negative 1? Well, this is actually why that is. Suppose I decided to rewrite the fraction, but when I rewrote it, I switched the order of the numbers in the denominator. Then I decided to factor out a negative 1. When I did that, notice I now have an x minus 3 in the top and an x minus 3 in the bottom. All I'm left with is negative 1. So that's actually the reason why opposite factors cancel to negative 1. The important part to know is that they do. Let's take a look at our first example. Example 4. Do you see anything here? That's right, we have opposite factors, and so those cancel to negative 1. Don't forget we have to state our undefined values. This expression is undefined at x equals 5. In example 7, we once again want to factor. Please pause the video here, factor, and simplify this expression. We have 2 minus x over 2x plus 7 and x minus 2. 2 minus x and x minus 2 are opposite factors, and so they reduce to negative 1. I usually just put the negative 1 right in the numerator. That leaves us with negative 1 over 2x plus 7, with the fraction being undefined at negative 7 halves and 2. And so here's what you need to know. When you want to simplify a fraction, factor the numerator, factor the denominator, and then cancel things that are exactly identical. And that's everything you need to know about simplifying rational expressions.